let's talk about switch and LED combination in embedded C by using Keil and Proteus combination. So just double click on your Keil microvision. This is the previous default project file, just close it. Now so we are developing the project for switches with individual LEDs control. Okay, so for that just choose your project tab from your Keil microvision and choose the option new project and give your project name. Save. Now so choose your controller manufacturer from the list of all manufacturers. You can choose any manufacturer of your microcontroller families. So now I select Atmel and just click on plus mark. It will show the list of devices from this Atmel manufacturer and choose the device, click on OK. And this is a startup code file. If you want to add for your project, you can click on S, otherwise no. Now so open your editor window. For that go file tab and choose the option new and save this text editor before writing program. For that file and click on save. So what's your project? Switch LED. And you have to save your project program file with .c extension because we are using embedded C language to develop this application. So this is your file and start write your program. And this is the header file name for all 5.1 families, and try to declare your hardware connections in your embedded C program. So for accessing individual IOs, try to use a specific keyword in embedded C programming, which is S-bit data type, and give your user defined name. And this is the LED user defined name. Just I want to control 4 LEDs with 4 switches. LED 1 and this LED 1 which is connected with P1.0 pin, and next so I am connecting one more LED with one more IO line. Next, so whenever you are looking to operate individual IOs, you have to declare individual connections with individual IO pins. So these are 4 LEDs we are connecting with P1.0, P1.1, P1.2, P1.3. So whenever you are looking to control those 4 LEDs with 4 individual switches, again you people need switches declaration also. So now I am taking 4 switches, 4 individual switches for 4 LEDs with corresponding switch names. So this is SW1, and these switches I am connecting with other IO port which is P2.0. and the second switch which is connected with P2.1, and the third switch I am connecting with P2.2, and switch 4 which is connected with P2.3, and all port bit names which are in capital letters, because all SFR registers, so which allows port names in capital letters only. So these are all individual switches declaration. This is the complete individual declarations for your corresponding LEDs with corresponding switches. Now your main program starts. So according to embedded C programming, you people have to declare your port connections, either input configuration or output configuration, from your hardware interfaces. Now all LEDs which are connected with port 1, right? So you have to declare your port 1 as output. For configuring output, you have to apply logic zeros. This is the configuration required whenever you are looking to choose the IO pins as output, and by default all pins which are used as input only, so there is no need to configure. And if you want to understand clearly, then you can apply the same logic as FF. This is for input configuration, and by default also these pins will work for input. This is default status. Now, so you people have to apply the conditions based on your hardware connectivity. So how your switches which are connected with your hardware, one terminal which is connected with ground and other terminal which is connected with IO. So once you are closing your switch, the logic will become 0. So you have to write the condition for logic 0 in the if condition. So if switch equals to 0 means just I am checking my condition for logic 0. So otherwise switch terminal 1 and ground, and other end IO pin. So now, so you people can apply the logic of LED 1. So before your LED 1s are zeros, right? Now I am giving logic 1 for this LED 1. If switch equals to 0, which logic remains 1, and when it will become 0, so until unless if switch remains 0, it will stay there on. So this is the condition for if you keep on press your switch, LED remains high, LED will glow continuously. If you leave your switch, then LED will off. Next, the same other condition I am writing for switch 2. Now LED 2 will become 1 because I'm operating switches, individual switches with individual LEDs, and these thing you can keep it on infinite loop, which is while. So your program will monitors continuously with the help of this while loop. So if you are looking to turn on your LED, if you keep on press your switch 2, then you can add this switch 2. So what is the meaning of this while here? If it is remains same switch 2, if you keep on press, then it stay there only, otherwise it will go for next step. If you leave your switch, then it will go for check other condition. Next, so this is for switch 3, and if you are operating switch 3, then you have to turn on your LED 3, and this LED will glow until unless if you are not releasing your switch. If your switch 3 is pressed, then LED will remains logic 1, and the same condition you have to apply for switch 4. And this logic 1 which will maintains until your switch is pressed. Suppose if you are not operating any switch, then all LEDs logics will become 0. And close your while loop and close your main. So this is the program for operating your individual switches with individual LEDs. So after writing this program, just save with the help of save button, and you have to run this program on a specific target device. Just click on plus mark with this target 1 and select your source group 1 and right click it, and you have to add your embedded C program for your target device by choosing the option add files. Now, so what is your program? Switch LED. Click on add and close it. So if you want to verify whether program is added or not, you can click on this plus mark. It will show your file, which program you are going to compile. So for verifying your errors and warnings from your program, go project tab and choose the option build target. So after getting 0 errors, 0 warnings, then you can go for debug session. So if you are looking to debug session, you can debug your program. And to verify the IO pins logics, go peripheral tab and open your IO ports. So whatever IO ports used in the program, so I used port 1 and port 2, right? So just open the IO ports logic, and by default which are maintaining FF, and input configuration doesn't require. So run your program. See, initially all the status of P1 logics are zeros. If I press switch 1 from port 2, you can see the response from your port 1 IO pin, so which is keep on glow, and if I release this, then it remains 0. So for 4 switches, you can see the response from your 4 IO pins. So this is the way you can test your program by using debug session, And if you are looking to hardware simulation, then you have to create hex file. So just stop the debug session by again choosing debug tab and select the option same start or stop debug session. First stop the running and you can stop debug session. So till now our people compiled and debug our program. Now I am looking to execute this complete embedded C program on Proteus. So for that, select target 1 and right click it and choose the options for target 1, and this is the external oscillator frequency you have to assign for your controller. So with the same frequency your X file will create by microcontroller, and highlight this use on chip ROM. In the same window choose output tab and highlight this create hex file and click on OK. After giving all these options, then go project tab and build target. So now it will show the hex file path for your embedded C program. Just to minimize your development tool and open your Proteus tool for verifying your hardware results. So you people can open your Proteus tool for checking your hardware results. So pick the devices from the library by using this P symbol and choose the microcontroller, whatever you want. And you are looking for switches, right? So just type button keyword for taking your switches. And choose the option add LED. And place your components in the design. And select the buttons. So you people connected where, which are all connected with P2 IOs, right? Just place your switches in a order. And take your LED connections. You can rotate by using these rotation symbols, and these LEDs you can rotate because the anode should be connected with port 1 and cathode should be connected with ground. So these 4 switches connections, how we have to do: one terminal which is connected with IO pin and other terminal has to connect with ground. So for taking ground, just choose the terminals mode and select the ground, which required for switches and as well as LEDs. So just connect your other terminal of switch which is connected with ground. The same thing for other switches. So switch one terminal which is connected with IO pin and other terminal connected with ground. And LED, you have to connect anode end with IO pin. All anode ends of your LEDs which are connected with IO pins. and the cathode ends of your LEDs which are connected with ground. So after doing your all hardware connections with the controller, just browse your hex file from Keil Microvision. If you double click on controller, it will ask for program file path. Just click on this folder symbol and choose your hex file from specific path from your my computer, and choose your hex file and give same clock frequency how much you created your hex file with how much frequency. This is 11.0592 and click on OK. So now you can see hardware simulation just by using this play symbol. See, so the initial response from your LEDs will be off, and once I started operating switch, then you can see the response from the corresponding LED. If I release the switch, then LED will off. If I keep on press, LED status remains high. Next, if you want to operate the second LED, you can operate your second switch. So if you keep on press this, then LED remains high. Then third switch for third LED, and fourth switch for fourth LED. And you people can see the response with the corresponding switches. This is the program for operating individual switches with individual LEDs. If you want to stop simulation, you can use the stop symbol. Thank you.